Text. Yes. Hello. Welcome to another video. Here we have yet another math problem. Fuck yeah. Okay, so what do we have here? We have that a squared plus 2 to the power of a for positive integers a is never divisible by 6. How do we show this? Well, we start by thinking this. What is 6? What is 6? 6 is 2 times 2. Yeah, 6 is 2 times 3. So what does this mean? This means that if something is divisible by 6, then it is obviously also divisible by 2 and 3. So, if something is divisible by 2, then it's even. So, what does that say about this left-hand side? Okay, that thing is obviously always even. This thing. Oh. Okay, if A is even, an even number squared, that's always an even number. An odd number squared, that's always an odd number. So the first thing we can state is that A for so now we're basically doing a proof by contradiction here. Okay, so we're trying to find an A such that it 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 doesn't hold, meaning that it is divisible by 6. So so if we want this, we say that okay, A has to be even for it to hold. So that's the first thing. And then we can look at this thing modulus 3. So what do we have then? Okay, so we know that a squared plus 2 to the power of a modulo 3 is supposed to be equal to 0. So we can rewrite this left-hand side. So we can just start with the fact that, okay, what is 2? 2 is the same as minus 1 modulo 3. So we have that a squared plus minus 1 to the power of a is supposed to be divisible by 3. And we know that a is even. So we can think about that. So what does this mean then? Okay, if a is even, then we can describe a as, we can say that a is, we call them 2n. What do we have then? Okay, so we have that 2n squared, which is 4n squared, plus minus 1 to the power of 2n. Okay, yeah, minus 1 to the power of 2n. What is this? Since you obviously know your exponent rules, then we can do this thing. We know that this is the same as minus 1 to the power of 2 to the power of n. And what is minus 1 squared? That is 1. So we have that this is just 1 to the power of n, which is just 1. So this is 4n squared plus 1. And this thing is supposed to be divisible by 3. And since 4 is 3 plus 1, we can just remove this also. So we have that n squared plus 1 is supposed to be divisible by 3, meaning that n squared modulo 3 has to be equal to 2 for this to make sense. And is this ever the case? Let's find out. If any integer squared is any integer squared equal to 2 modulus 3? Well, first we can just think of it. Okay, so we have 1 squared, that's 1. Okay, divisible equal to 1. 2 squared, that's 4. That's also equal to 1 and modulus 3. 3 squared, that's 9. 4 squared, that's 16. Divisible by 3, no. And it has the residue 1. So, and then the pattern repeats. So we have 5 squared, that's 21. Also is equal to 1 modulus 3. So it seems we never get a 2, but we can prove this mathematically, of course. So if n is divisible by 3, then it obviously is divisible by 3. So we don't even have to regard that case. So the first is if n is divisible, it is equal to 1 modulus 3. That gives us, and then we say that n is equal to 3k plus 1. And then it gives us that, okay, so we have 3k plus 1 squared. This modulo 3, what is this? Well, all the times 3 disappears, so we just get a 1 left. So this is just a 1. And 1 is not equal to 2, not even in modulus 3. So this does not work. And then we have the other case. 3 mod n modulus 3 is equal to 2. Then we say that n is equal to 3k, for k some integer obviously, plus 2. So then get the same thing here. 3k plus 2 squared. What is that in modulus 3? Well, the same thing here. Everything except the last term disappeared because they all have a factor of 3. So what we have left is just 2 squared. And what is 2 squared is 4. And 4 modulus 3 is just 1. So it never holds. So therefore, we have proven by contradiction that we arrive at something that is not possible, and therefore this can never be the case. And that was all for me. Bye bye.